Preparations of alkyl halides. Alkyl halides are amongst the very important reagents for the manufacture of other organic compounds, but mainly they are used in the manufacture of paints, refrigerant gases, anesthesia, solvents, aerosols, propellants, and so on. So, the need of their preparation is an important industrial activity because they are rarely found in nature. The first reaction is the preparation of alkyl halides from alkenes or alkynes by addition of hydrogen halide. Addition of halogen acid to alkene or alkynes gives alkyl halides as the products. The orientation in the addition reaction is described by Markovitch's rule. For further explanations, confirm chemical properties of alkynes and alkenes. Let us have an example. Here we have a propene reacting with hydrogen bromide in organic acid as a catalyst to give a mixture of two products, 1-bromopropane and 2-bromopropane. But 2-bromopropane is a major product and the 1-bromopropane is a minor product as predicted by Markovitch. Let us have the mechanism of the reaction. This is going to help us to understand well why do we have two products and why one of them is the major product. We have two reagents, hydrogen bromide having partial positive charge on hydrogen and partial negative charge on bromine, and we have a propene having high density of electrons between the two double bonded carbons. Now, the positive charge on hydrogen is going to attract electrons from the double bond, and these electrons are going to repel the electrons of the bond between hydrogen and the bromine, and this produces two possible products. Because there is a formation of a bond between hydrogen and the carbon, there is one product where the hydrogen is added on the left side of the chain, or there is another product where hydrogen is added in the middle. It means that the carbon on the left is going to get hydrogen and the positive charge is formed in the middle, or the carbon in the middle is getting hydrogen and the positive charge is formed on the left side. So we are going to compare the stability of these carbocations. If you remember well, the stability of carbocations is like this. Tertiary carbocations, they are more stable than secondary, more stable than primary. And here we have a secondary and primary. Here now, the secondary carbocation is more stable than the primary carbocation. Let us look at the next step. The carbocations formed are going to be stabilized by the nucleophile in the medium, and here we are going to use the bromide ion. Bromide ion is going to donate electrons to the carbocation and form a dative covalent bond between the carbon and the bromine. And another molecule also is going to be formed. Here we are going to produce two molecules. One is 1-bromopropane, another is 2-bromopropane. So which one is the major? It will be the one which came from the most stable carbocation. So it will be 2-bromopropane. The second preparation is the preparation of alkyl halides from alkanes by substitution reactions. Direct halogenation of alkanes in the presence of ultraviolet light or high temperature gives alkyl halides and hydrogen halide. Note: with excess halogen, the final product will be polyhalide instead of being monohalide. Let us have an example. The general equation is R, which is an alkyl group, H, plus X2, which is a halogen, under ultraviolet light. It gives Rx plus Hx. An example, here we have a methane which is going to react with the chlorine under UV light, and it gives chloromethane plus hydrogen chloride. As you can see here, it is mono substitution because only one hydrogen has been replaced by one chlorine. Mechanism of chlorination of methane. I think you remember this reaction in the chemical properties of alkanes. The overall reaction Methane reacts with chlorine under UV light to give chloromethane and hydrogen chloride. The reaction happens in three main steps: chain initiation, chain propagation, and chain termination. In chain initiation, the chlorine-chlorine bond is broken by the UV light to give two chlorine free radicals. The free radicals formed, which are the high reactive chemical species with single electrons, are going to attack the molecules in the medium, starting from methane, which is rich in electrons, and chlorine subtract hydrogen atom from the methane molecule to give methyl free radical and hydrogen chloride. The methyl free radical formed is also unstable. It is going to attack the chlorine molecule and subtract chlorine atom to give chloromethane and the chlorine free radical. The propagation continues until all molecules are attacked. And then the chain termination is going to combine all the free radicals formed in the propagation state. Here we have chlorine reacting with another chlorine to give chlorine molecule. We have methyl reacting with chlorine to give methyl chloride molecule. And we have methyl reacting with another methyl to give ethane molecule. And as you can see, this reaction produces a mixture of products. Look at this. This is generally a poor method of alkyl halide preparation because mixtures of products invariably result. This reaction does not stop at the monochlorination state, but continue to give dichloro, trichloro, and even tetrachloro products. Furthermore, alkanes having more than one kind of hydrogen gives more than one kind of monochlorination product, in addition to polychlorination products. Relative reactivity. The reactivity of halogens ranks as follows. Fluorine is the most reactive, while iodine is the least reactive. Fluorine is the most reactive because it is the most electronegative, while iodine is the least reactive because it is the least electronegative. And the reactivity order of alkanes depends on the stability of alkyl radicals formed during the reaction processing. Let us use these examples. An alkane which has primary carbon is the least reactive, while an alkane which has tertiary carbon is the most reactive, which means that the reactivity of alkanes increases from primary to the tertiary alkane. This is due to the stability of free radicals formed. The primary free radical is the least stable, while the tertiary free radical is the most stable. The stability of free radicals increases from primary to tertiary free radicals. The third preparation is preparation of alkyl halides from alcohols by substitution reactions. Alcohols react with a number of reagents to produce alkyl halides. They react with ethyl chloride in pyridine, they react with phosphorus halide in pyridine, they react with acid halides in acidic medium, but because hydrogen chloride reacts hardly, anhydrous zinc chloride, which is a Lewis acid, is used as a catalyst to make a very good living group. Here we have examples. Methane which reacting with ethyl chloride, we have ethanol which reacting with phosphorus tribromide, ethanol reacting with the phosphorus pentachloride, and the propanol which react with the hydrogen chloride. Let us have the mechanism of the reaction between 2-propanol and hydrogen chloride. Alcohol is attacked first by the zinc chloride, which is a Lewis acid, and it is going to take electrons from oxygen of the alcohol to form a dative covalent bond, which will result in the formation of a complex ion. Here we have positive charge on oxygen and a negative charge on zinc. The hydroxy zinc chloride, it is a good living group. That is why if we have chloride ion from hydrogen chloride, which is a good nucleophile, and this attacks on the electron deficient carbon, the electrons of the nucleophile will repel electrons of the bond between carbon and oxygen and makes this bond break and produces an alkyl halide and the zinc hydroxychloride complex ion. Hydrogen bromide and hydrogen iodide can react without a catalyst, and the mechanism in this reaction is SN1. The first step, the OH group is first protonated by the hydrogen bromide to form a good living group, which is water. Second step, there is spontaneous dissociation of the protonated alcohol, which occurs in a slow and rate limiting step to yield a carbocation intermediate plus water. And the last step, the carbocation intermediates react with the bromide ion in the first step to yield the neutral substitution product. The fourth reaction is preparation of alkyl halides from more aldehydes or ketones. Both aldehydes and ketones react with the phosphorus pentachloride to give geminal halides. Examples. Here we have propanol, which is an aldehyde reacting with the phosphorus pentachloride to give dichloropropane, and we have acetone, which reacts with the phosphorus pentachloride to give dichloropropane. The only difference between the two products, one is 1,1-dichloro, another is 2,2-dichloropropane. The fifth preparation of alkyl halides is the preparation from alkynes and alkenes by addition reaction of halogen. Halogens, chlorine, bromine, and iodine are added to alkenes or alkynes to give di or tetrahalide respectively. For further explanations, confer chemical properties of alkenes and alkynes. Examples. Propane reacts with 1 mole of bromine to give 1 and 2-dibromopropene, which is then reacting with another mole of bromine to give 1,1,2,2-tetrabromopropane. Or another reaction is propene reacts with 1 mole of bromine to give 1 and 2-dibromopropane. Thank you for your kind attention. The next topics will be on the uses of alkyl halides.